Mole calculations involving gas volumes for Cambridge International GCSE Chemistry. Starting with a review of stoichiometry, we'll discuss the units of gas volume, molar gas volume, how to convert between moles and volume, and then calculating reacting volumes based on balanced chemical equations. The reacting mole ratio is the ratio in moles of each substance reacting and being formed in a chemical reaction. And of course, this is seen in the balanced chemical reaction. For example, the reacting ratio between hydrogen and oxygen is 2 to 1, and the formation of water is 2. So we have a ratio of 2 to 1 to 2. That's the reacting ratio, but it is a reacting ratio in moles. So 2 moles of hydrogen reacts with 1 mole of oxygen to form 2 moles of water. That is a fixed ratio. It is always 2 hydrogens to 1 oxygen to 2 waters. Regardless of the amounts actually involved, the ratio will always be 2 to 1 to 2 in moles. Moving on to the units of gas volume, there are 2 that are used, centimeters cubed and decimeters cubed. 1 decimeter cubed, sometimes called a litre, is 1,000 centimeters cubed. In reverse, 1 centimeters cubed is 0.001 decimeters cubed. Now you'll be expected to convert between centimeters cubed and decimeters cubed. So here are 4 problems. See if you can complete the volume in decimeters cubed, convert 3 decimeters cubed into centimeters cubed, etc. Pause, come back when you're ready to check and correct. Okay, so (200 centimeters cubed is 0.2 decimeters cubed. How's that achieved? It's 200 divided by 1,000. Okay, so to convert centimeters cubed into decimeters cubed, you divide by 1,000. 3 decimeters cubed is 3,000 centimeters cubed, and we achieve that. It's 3 times 1,000. So to convert decimeters cubed into centimeters cubed, you multiply it by 1,000. If you haven't been successful on the first 2, pause and complete the next 2 calculations. If you have been successful, I'm going to reveal 0.025 decimeters cubed, 25 centimeters cubed, and 0.05 decimeters cubed is 50 centimeters cubed. Molar gas volume. The volume of gas, of any gas, is not decided by the molecular size, but by the numbers of particles. Now, at all times at GCSE, we will be working at room temperature and pressure, RTP. So we have constant temperature and pressure. So if we look at my picture, we've got 7 gas particles on the left and 7 gas particles on the right. The gas molecules are of different sizes, but the volume occupied is the same. The same number of gas molecules occupies the same volume. This is because the volume is principally decided by the distance apart of the gas molecules. The size of the gas molecules has no impact on the total volume. By experiment, the volume occupied by 1 mole of any gas has been determined, and 1 mole of any gas occupies 24,000 centimeters cubed. This is called the molar gas volume at room temperature and pressure. So 1 mole of any gas occupies 24,000 centimeters cubed. You'll be using that figure in gas volume calculations. Alternatively, 1 mole of gas molecules occupies 24 decimeters cubed. Again, you will be using that figure in volume calculations. They're the same volume, but different units. So we've been through reacting mole ratio, units, and molar gas volume. We'll now see how to convert between moles and volume and moles. So we are going to use the molar gas volume to calculate the volume of any gas. The molar gas volume is 24 decimeters cubed. I'm going to work in decimeters cubed at the moment. It's simply the number of moles times 24 will give you the volume of any gas in decimeters cubed. So let's do an example. What is the volume of 2 moles of hydrogen gas? Well, 2, that's the numbers of moles, times 24, that's the molar gas volume, comes to 48 decimeters cubed. Convert that into centimeters cubed, 48,000 centimeters cubed. So here's an incomplete table. 5 gases. We've got the numbers of moles for 3 of them and the volume for 2 of them. Could you calculate the volume occupied by the number of moles and the numbers of moles that reflects the volume? Pause. Complete. Come back to check and correct when you are ready. Okay, so the first answer is 6,000. I got that by 0.25 times 24,000. 1.5 moles is 36,000 centimeters cubed. That's 1.5 times 24,000. I hope it's seemingly obvious. 12,000, 0.5 times 24,000. But what about this next feature? How do we calculate the numbers of moles? Well, we're simply going to rearrange this equation so we isolate the number of gaseous moles as equaling the volume of gas divided by 24,000. All I've done is bring down, divided both sides by 24 decimeters cubed or 24,000 centimeters cubed. So numbers of moles is the volume divided by 24,000 if the volume is in centimeters cubed, and I am working in centimeters cubed. So if you haven't completed these two, pause and complete. If you have, and you're now ready, here's the answer, 0.1. That's simply 2,400 divided by 24,000. And similarly, 1,200 divided by 24,000 is 0.05 moles. So from the volume of a gas, we can calculate the numbers of moles. From the numbers of moles, we can calculate the volume of gas. Simply using this or rearranging this relationship, the volume of any gas is the numbers of moles times the molar gas volume, 24 decimeters cubed, or 24,000 centimeters cubed. The volume of any gas can also be calculated from its mass. For example, calculate the volume of 4.4 grams of carbon dioxide, CO2. Well, the first step is to convert the mass into a number of moles. So that's 4.4, the mass, divided by 44, the molar mass. That comes to 0.1 moles. Then step 2, convert the numbers of moles into a gas volume as on the previous slide. Numbers of moles times the molar gas volume in decimeters cubed or centimeters cubed comes to 2.4 decimeters cubed. Just to be absolutely clear, where does the 44 come from? 12 for carbon, 2 times 16 comes to 44. So that is the relative molecular mass of carbon dioxide, which in grams is the molar mass. So the mass of 1 mole is 44 grams. So 4.4 divided by the mass of 1 mole. The molar mass comes to 0.1 moles. So here's a task for you. Calculate the volume of 0.32 grams of sulfur dioxide, SO2. Pause. Complete the calculation. Come back to check and correct when you are ready. So I'm about to reveal. Moles of sulfur dioxide, 0.32, that's the mass, divided by 64, just to be clear. Sulfur is 32 and 2 times 16 for oxygen. That comes to 64. So 1 mole is 64 grams. Comes to 0.005 moles. Step 2, volume of sulfur dioxide is the numbers of moles times the molar gas volume, 24 decimeters cubed or 24,000 centimeters cubed, but for ease of presentation I've used 24, comes to 0.12 decimeters cubed. So we can convert a mass into a numbers of moles and then convert the numbers of moles into a gas volume by multiplying by the molar gas volume. We can use molar gas volume to calculate reacting volumes of gases from a balanced chemical equation. Let's start with a model problem. Calculate the volume of carbon dioxide produced by the decomposition of 8.4 grams of magnesium carbonate. So we need a balanced chemical equation, and within that we can see that 1 mole of magnesium carbonate produces 1 mole of carbon dioxide. The reacting mole ratio is 1 to 1. So the first step is to convert the mass of magnesium carbonate into a numbers of moles. So 8.4 divided by the molar mass of magnesium carbonate, 84, comes to 0.1 moles. Predict the moles of carbon dioxide produced using the reacting mole ratio. Well, 1 mole of magnesium carbonate produces 1 mole of carbon dioxide. 0.1 moles of magnesium carbonate produces 0.1 moles of carbon dioxide. And then step 3, convert that numbers of moles into a gas volume by multiplying by the molar gas volume. I'm using decimeters cubed. So 0.1 times 24 comes to 2.4 decimeters cubed. So we can predict that 8.4 grams of magnesium carbonate produces 2.4 decimeters cubed of carbon dioxide. So here's the balanced chemical equation for sulfuric acid and magnesium forming hydrogen and magnesium sulfate. You'll see it's a 1 to 1 to 1 to 1 reacting mole ratio. Given that, here's your task. Calculate the volume of hydrogen formed by the reaction of 1.2 grams of magnesium. Pause, Think it through, carry the calculation out, come back to check and correct when you are ready. Okay, so I'm about to reveal. The first thing to do is to convert 1.2 grams into a numbers of moles of magnesium, which we achieve by dividing by 24. The molar mass of magnesium comes to 0.05 moles of magnesium. It's a 1-to-1 ratio. Magnesium to hydrogen is a 1-to-1 reacting mole ratio. So 0.05 moles of magnesium will form 0.05 moles of hydrogen gas. Third step, what's the volume of that numbers of moles? It's simply the numbers of moles times 24, gives me 1.2 decimeters cubed. So like all calculation topics, this topic needs some practice, so find some problems in your textbook or online for which you have access to answers so that you can check and correct your thinking. Then move on to past paper questions. If you've found this lesson helpful, please recommend it to a friend. Please like and subscribe if you feel so inclined.